Today we will do electric field due to a system of charges. Now, as we have seen in this diagram here, we have n number of charge, q1, q2, q3 up to qn, which is at a position vector r1, r2, r3 up to rn. So here we are going to find the electric field intensity or electric field at point P, which is at a position vector r from the origin O. Now, because of the presence of so many charges here, so we will have the electric field at point P is because of charge Q1, which is given by E1, and the electric field at point P due to charge Q2, which is given by E2, and so on up to the electric field due to charge Qn, it will be En. Now, here when we try to, let us say, get the total electric field at point P, or the electric field intensity at point P, we have to add this electric field due to Q1, Q2, Q3, and so on. That means we have to add E1, E2, E3, E4, and so on. So since E1, E2, E3, or the electric field is a vector quantity, we have to add them by parallelogram law of vector addition by taking two of them. Like for example, in this case, I take E1 and E2, then we add it by parallelogram law of vector addition, we get this vector which is marked by red. Again, this vector which is marked by red is again added with E3 to get this vector or the electric field which is marked by green. Again, in that way we will continue two vector at a time, we will add it, or two electric field at a time we will add it till we get the final let us say electric field at point P because of the electric field E1, E2, E3, and so on. So that will be the total or the electric field intensity at point P because of the all the charges like Q1, Q2, and so on. Now let us write it. Let us write about electric field first. So electric field at a point due to a system of charges, is the vector sum of the electric fields at the point here, in this case at point P, due to individual charges. Now let us consider a system of charges given by Q1, Q2, and so on up to Qn. Okay, with position vectors R1, R2 up to Rn relative to origin O. Now electric field E1 at R, at a position vector R, that means at P, due to Q1 at R1 is given by E1, which is equal to 1 by 4 pi epsilon naught Q1 by R1P square, R1 P cap. Name this as equation 1, where we can write here R1P cap is a unit vectors, is a unit vector in the direction is a unit vector. R1P is a unit vector in the direction from Q1 to P. Okay, and now the magnitude R1P is the distance between Q1 and P. Now in the same manner we can write for E2 in the same manner. We can write electric field E2 at R, electric field E2 at R, which is at point P, due to Q2 at R2 is given by E2, which is equal 1 by 4 pi epsilon naught Q2 by R2P square R2P cap. Name this as equation 2. Here also we can write where R2P cap is a unit vector in the direction from Q2 to P, and the magnitude R2P is the distance between Q2 and P. So similarly we can write for E3, E4 up to En. So similar expression, we can write that similar expressions holds good for fields. E2 is finished. Now E3, comma E4, comma up to, comma En. Okay. Due to, we can write here, due to charges Q3, comma Q4, comma up to, comma Qn. Okay, so now by superposition principle, let us write it. Now by superposition principle, the electric field E at R due to the system of charges is given by E at R, electric field at R, at the position vector R, will be equal to the electric field at a position R, position vector R, I mean to say, because of the charge Q1, plus the electric field at a position vector r because of charge q2 plus up to plus the electric field at position vector r because of charge qn. Now if we substitute the value of E1, E2, E1 from equation 1 and E2 from equation 2 and so on up to En, we have, or we substitute the value of E1, E2, now E R, then it will be equal to 1 by 4 pi epsilon naught from that equation 1. It will be Q1 by R1P square R1P cap plus Q2. Q2 is 1 by 4 pi epsilon naught Q2. Then it will be the term Q2 R2P square R2P cap plus the last term plus the last term. Last term is En, so it will be 1 by 4 pi epsilon naught Qn by Rnp square Rnp cap. Now we have seen that the term 1 by 4 pi epsilon naught is present in all the terms, so we take it common. So or E R is equal to 1 by 4 pi epsilon naught, take common. So from the first term it will be only Q1 by R1P square R1P cap remain, plus from second term is only Q2 by R2P square R2P cap remaining, plus plus the last term it will be Qn by Rnp square Rnp cap remaining. Now close bracket, or E vector r is equal to 1 by 4 pi epsilon naught. Now in terms of summation it will be I is equal to 1 up to n. Here it will be Qi by Rip square Rip cap. We name this as equation 3. Now equation 3 is the required equation. The required equation. It gives the electric field at point P with position vector R due to a system of charges Q1, Q2, up to Qn. Now we know that E is a vector quantities. Now E is a vector quantity, Now E is a vector quantity that varies from one point to another point in space and is determined from the positions of the source charge or charges of the source charges. So E is a vector quantities that varies from one point to another. So for example, if we consider point P and another point somewhere here in this point Q, so E will not be the same at point P and point Q. So they will varies from, or they will be different at point P and point Q. Now, and also it is determined or determined from the portion of the source charges. So it will also be determined from the portion of the source charges like Q1, Q2, Q3, and so on. So with this, we complete the topic today. Thank you.